Hello everyone, myself Umi Mehta, and in operating system, let us understand what is deadlock. So in this session, we understand what is deadlock, its definition, and what is the characteristic of it. So first of all, what is deadlock? For many applications, a process needs exclusive access to not one resource but several. Suppose, for example, two processes each want to record a scanned document on a Blu-ray disc. Process A requests permission to use the scanner and is granted it. Process B is programmed differently and requests the Blu-ray recorder first and is also granted it. Now, A asks for the Blu-ray recorder, but the request is suspended until B releases it. Unfortunately, instead of releasing the Blu-ray recorder, B asks for the scanner. So this is the situation. At this point, both processes are blocked and will remain so forever. The situation is called deadlock, which means that process A requests to something which is halted by process B, and for completion of process B, it requests to resource which is halted by process A. So this is the situation that both of these processes are blocked and will remain in the same situation. So this situation is called a deadlock. So a deadlock consists of a set of blocked processes, each holding a resource and waiting to acquire a resource held by another process in the set. So this is the basic definition, that in the deadlock situation, it consists a set of block process, each holding a resource and waiting to acquire resource held by another process in the set. Deadlock can also occur in a variety of other situations. In the database system, for example, a program may have to log several records it is using to avoid race condition. If process A logs record R1, process B logs record R2, and then each process tries to log the other one's record, we also have a deadlock. So this is the situation that deadlock occur in software resource also. So this deadlock can occur on hardware resources or on software resources. So deadlock can occur when processes have been granted exclusive access to devices, files and so forth. These objects are referred as resource. Now resource can be hardware or it also be piece of information. Now we can categorize to resource as a preemptible resources or non-preemptible resources. Now what is preemptible resource and what is non-preemptible resource? So let us discuss first of all what is preemptible resource. A preemptible resource is one that can be taken away from the process with no side effect, which means that we can take resource from the process without any side effect. So memory is an example of preemptible resource, that we can take memory from the processes. So consider, for example, a system with 32 MB of user memory, one printer and 232 MB processes that each want to print something. Now process A requests and gets the printer, then starts to compute the values to print. Before it has finished with computation, it exceeds its time quantum and is swapped out. Now process is swapping. So this is the concept of process scheduling, that after some duration of time, its a time slot is complete, so it is the process is out from the CPU and next process is come to execute in the CPU. So now process A is its time quantum is complete and now it's swap out. Now process B runs and tries to print unsuccessfully to acquire the printer. Now process B cannot acquire the printer. Potentially we now have a deadlock situation because A has the printer and B has the memory, and neither can proceed without the resource held by the other. Fortunately, it is possible to preempt the memory from B by swapping it out and swapping A in. Now A can run, do its printing and then release the printer. Now no deadlock occur. So this is the possible solution, that if we take away memory from B by swapping it out and we swapping in process A. Now we are giving memory and printer to both to process A. So process A complete its task. After that, process A release printer and the deadlock situation is not happen. Now what is non-preemptible resources? So a non-preemptible resource in contrast is one that cannot be taken away from its current owner without causing the computation to fail. So this is the situation that we cannot take away resources from the process. For example, if a process has begun to burn a CD-ROM, suddenly taking the CD recorder away from it and giving it to another process will result in grabble the CD. And CD recorders are not preemptible at any arbitrary moment. So, we can say that in general, deadlocks involve non-preemptible resources. Potential deadlock that involve preemptible resources can usually be resolved by reallocating resources from one process to another. So thus our treatment will focus on non-preemptible resources, because to solve deadlock in preemptible resources, we can easily taken away that resource from particular process, reallocate that resource, and we can resolve the deadlock situation. So in general, deadlocks involve non-preemptible resources. Potential deadlock that involve preemptible resources can usually be resolved by reallocating resource from one process to another. So we are only focused on the non-preemptible resources. So the abstract sequence of events required to use the resources given below. For example, this is particular resource, this is a process. So process request to the resource, use that resource and release that resource. So this is the three sequence: request, use and release the resource. Okay, so this is the situation that we can request for the resource, use the resource, and now we can take away from resource. Now what is the characteristics of deadlock? So deadlock can arise if four condition holds simultaneously. So all of four this condition must be present for a deadlock to occur. So if any one condition is not present, then there is no chance of deadlock. So these are the four conditions. First is mutual exclusion, in which only one process at a time can use a resource. Second condition is hold and wait. So a process holding at least one resource is waiting to acquire additional resource which is held by other processes. This is condition hold and wait. The next is no preemption. So a resource can be released only voluntarily by the process holding it after the process has completed its execution. We cannot preempt, we cannot take away resource whenever there is process is ongoing. The next one is circular wait. There exists a set P0, P1 up to Pn of waiting processes such that P0 is waiting for a resource that is held by P1 P1 is waiting for a resource that is held by P2 and so on, and Pn minus 1 is waiting for a resource that is held by Pn, and Pn is waiting for a resource that is held by P0. So this is the situation like this. Now this is waiting for this resource. Now again some another procedure. This is process, for example P0. So this is given to this process. Now it is waiting for a resource and which is given to this process. So this situation is circular wait. So if one of this condition is not happening, then there is no deadlock. But if this 4 condition is happen simultaneously, then deadlock occur. So this is the characteristic of deadlock. So basically what is deadlock? Whenever it happen, what is the main focus, which is on non-preemptible resources and its characteristic. That is the point that we have discussed in this session. Thank you.